Hello guys, I'm a teacher Masame. Welcome to Limboka Physics. We have a question below that states that the saturation vapor pressure of ether vapor at 0 degrees centigrade is 105 millimeter height of mercury, and at 20 degrees it is 440 millimeter height of mercury. The bulb of constant volume gas thermometer contains dry air and sufficient of ether for saturation. If the observed pressure in the bulb is 1000 millimeter height of mercury at 20 degrees centigrade, what will it be at 0 degrees centigrade? Let us consider the diagrams below that elaborate this scenario. We have a bulb containing ether and air enough for saturations with our thermometer here. This is like a water trough or jar that holds this bulb with ice and water. The temperature reads 0 degrees centigrade, and in Bourdon gauge it reads a pressure 1, total pressure at 0 degrees centigrade, which is unknown. And for the second case is when the temperature rises to 20 degrees centigrade, it's read pressure 2, total pressure 2, which is 1000 millimeter height of mercury. And as you can see, thermometer raised up a little bit in order to read 20 degrees centigrade. Here it's ether as usual, and molecule of air and molecule of ether. Now the ice water melty because heat raised up. Okay, from Dalton laws, for a first case at degrees centigrade, the total pressure will be equal to individual pressures that present inside the bulb, and saturation pressure for ether plus C pressure pressure for air was at 0 degrees centigrade. That is equation number 1. And equation number 2, this is total pressure that reads on a Bourdon gauge. That is saturation pressure of ether and plus C partial pressure of air at 20 degrees centigrade. And we know that T partial pressure also is equal to saturation pressures after saturations, because for those conditions the air is enough to saturate the ether. Also air is enough to saturate the ether. Therefore partial pressure is equal to saturation pressure for a particular temperature. Okay, now let us substitute from the equation 2. We substitute 200,000 millimeter of height of mercury, which is equal to a partial pressure or saturation pressure of ether at this 20 degrees centigrade, and plus the partial pressure of air that is unknown. Then we get this unknown as 560 millimeter height of mercury. Now we must find this partial pressure of air for a temperature of 0 degrees centigrade for this first case by applying pressure law, as you can see here. Then we'll have a final answer as a partial pressure at 0 degrees centigrade as 521.8 millimeter height of mercury. Now we come back to equation 1 so that we can see how we can find the total pressures of the mixture of the air and ether vapor. Now total pressure, it will be equal to sum of individual pressure of ether vapor plus the partial pressure of air. As you can, we have given the data for these known values. Then we substitute the known values indicating the partial total pressures of the ether inside the bulb at 0 degrees centigrade as 706.8 millimeter height of mercury. This is the observed pressure in the bulb at 0 degrees centigrade, which is approximately equal to 707 millimeter height of mercury. Thank you for watching. Please like, share, comments. Don't forget to subscribe this channel for more videos like this one. Okay.